Okay, so we're on 2A.2, part 3, which is our function notes, function transformation notes. So with function transformations, you're simply saying, can you translate left, right, up, down? Can you dilate? We call it stretch and a compress. Can you reflect over the X and Y axis? Okay. Can you do them individually? And then can you put them all together? Is what we're focused on. Okay. So again, it seems like, oh no, it's a lot, but it's really not. All right. For your part 1 notes, I try to condense them. So for part 1, we're going to go over horizontal and vertical shifts first. And then we're going to do examples of horizontal and vertical shifts. Okay. Um, so are we all? So up first, we have horizontal and vertical transformations with translations. So these are our translations. So if you want to write translations, that's what that says. It gets a little sketchy. All right. Vertical translations are going to affect your Y value. So they affect my English people. Please make sure I'm using the right effect. It's A, right? It's A1. Okay. They're going to affect the Y. All right. Meaning that if I'm affecting Y, what is that going to cause me to do? Up and down. So it's going to be your function plus a number. Okay. This is called function notation. Function notation means that the rule can apply to any function. Does that make sense? It's not just for quadratics, not just for absolute. The rule that is being set here can apply to any function. For any function, you're going to be translating it left, right, up, or down. Okay. So we're starting with K. Sometimes your K may be called a D in courses. It doesn't really matter, but the number that is being added outside away from X. So notice that your K is away from X. Okay. The number that is away from X. If you are adding, that means it's going to go up. If you are subtracting, that means it's going to go down. That's our vertical translation. All right. Horizontal. If vertical affects your Y, then horizontal is going to affect your X. Okay. Now, your X's, it's with the X. So your the variable change is going to be with the X, not away from the X. The thing that we need to note here is that X's are liars. That's why they should be an X. X's lie. Okay. Life lesson. If your X lied, just let them be. They're going to lie more to you at this age. Okay. It looks like I am subtracting H, but what's actually happening is I'm adding. Okay. When it says, this is supposed to be a plus sign, by the way. Your plus got cut off. When it says X minus 5, you're actually going to be adding to your X. When it says X plus something, you're actually going to be subtracting from your X. Okay. That's because when this says X minus 5, I'm actually going to the right. And the only way to move to the right is to add something, right? In order for me to move across the x-axis to the right, I have to add. When it says plus, I'm actually subtracting, and that's going to make me go to the left. The next part we're going to look at are the formal definitions that we are not writing down. I repeat, the next part we're going to look at are the formal definitions, and we're not going to do what? Write them down. All right. So formal definition here, a vertical shift. A vertical shift is a vertical translation. When you have f of x plus k, which is what we just said, all I'm doing is reiterating what we said. If you have f of x plus k, you're going to be shifted vertically up, right? If you have f of x minus k, you're going to be shifted vertically down. Make sense? Okay. Horizontal. Our x's are what? Liars. They lie, bro. All right. So that's because the original function is x minus h. Because the original function is x minus h. H already started off as a positive. Okay. H is already positive. So when you see y of f of x minus h, you are actually shifted horizontally right. Okay. When you see your function notation as y of f of x plus h, you're going to be shifted horizontally left. Okay. In order to go right, I am adding. In order to go left, I am subtracting. Make sense? All right, so let's dive into our examples. Okay, so now we're at our example. So our first example, you're gonna always start with the original function or the parent function. Our parent function is f of x equals x squared. Okay, can someone tell me what kind of function this is? Perfect, quadratic. So we start here with our quadratic. We're going to start with the values of our quadratic and plotting the points. All right. You always want to start the smallest. So we're going to start around. We're going to do -3, -2, -1, 0, 1, 2, and 3. I'm starting with my smallest values near 0. Does that make sense? So these are my smallest input values near 0. I'm going to input these values into x squared. I'm inputting into x squared. So my y is my output. Make sense? What is -3 squared? 9. What is -2 squared? -1 squared. 0 squared. 1 squared. 2 squared. And 3 squared. Okay? We're now going to plot these points. You should be able to plot points without looking at me. Pen like she's beautiful and curvilicious. All right, now we're going to go on to the next part. The next part says it wants us to obtain the graph g of x, and g of x is x squared plus 2. Okay? X squared plus 2. Notice that our plus 2 is away from our x, right? Because it's away from our x, that's our k. That means that it's going to affect the y. Does that make sense? So for g of x, my x values aren't changing. So your x values are going to stay the same, but you are getting new y values. And how are you getting those new y values? Plus 2. So for g of x, we're changing our y's by adding 2 to each one of our y's. So that would be 9 plus 2, 4 plus 2, 1 plus 2, 0 plus 2, 1 plus 2, 4 plus 2, that's not 2, and 9 plus 2. You don't need to write the plus signs. I'm writing them so you can see where those numbers are coming from. Does that make sense? Okay. So we end up with 11. We have 6, 3, 2, 3, 6, and 11. Agreed? So now for g of x, it's going to have the same x values, but it has its own new y values. Does that make sense? The x's were untouched. The y's are what is new. Okay? So we're plotting -3, 11, -2, 6, -1, 3. When you're plotting points, you need an x and a y. So when I come over here to plot that, I'm at -3. Oh no, I have to go off the board. That's okay. As you're plotting, please tell me if you notice a pattern. Yeah. You would think after 5 years of writing on this thing, I would be way better at it. Joke's on you. I'm not. Just gonna make that a real big dot. And there's my g of x. What do you notice happened to g of x compared to f of x? It went up 2 units, right? And that makes sense because what did we say what happens when you're adding on to the function? It's either going to go up or it's going to go down. All right, now we're on to h of x. So h of x, my change is away from the x. So I know that it's affecting the y. So to each one of my y values, what am I doing? Subtracting 2. So for h of x, we're going to be y minus 2. So for each one of these, I would start, you're going back to your original. So we're looking at the original because that's our y. And we're subtracting 2. So it's 9 minus 2. And all the way down. Because I'm not about to write it again. 9 minus 2 gives me 7. 4 minus 2 gives me. Yep. You didn't see that. 7. 2. 1 minus 2 gives you -1. 0 minus 2 gives you. And this is a quadratic. So these values are going to do what? Repeat. So again, I'm using the same x values, but I have new what? Y values. So we're changing the red. Did anyone find a faster and easier way to graph? Again, pretend I went through all the points and she's glorious. Okay, compared to the red, what happened to the blue? Went down 2 units. Okay, so once I realized what was happening, I didn't actually plot my points. I just went to the red, the points, and either went up or went down. Instead of like, oh, I need to remember the points. I know that they're going up and down. So I went to the red on the purple and said, okay, I need to move you up 2 units. 1, 2. I need to move you up 2 units. 1, 2. To get the blue, I need to move you down 2 units. I need to move you down 2 units. Does that make sense? So if you know what's happening and what these changes mean, and you have the graph, you can do it just graphically as well. Okay. All right. So did this change the domain of any of our functions? No, your domain is still what? Your domain is what? Your domain is all real numbers. It's a quadratic function. It goes forever to the left and forever to the right. So your domain is from -infinity to +infinity. However, what did change? The range for each one, right? So for each one, the range changed. For your parent function, your range was at 0 to infinity, right? And then for g of x, what did our range start at now? It started at 2. So the g of x, now we're at 2 to infinity. And then for h of x, what happened? H of x is now at, sorry, I forgot the r. The range is now from -2 to infinity. So causing your function to go up and down, that doesn't impact your domain, it impacts your range. And that's because what did we say we were changing to begin with? Your y values, right? And range represents your y. All right, questions about part 1. Can you make things go up and down so far? All right, so far about part 1. Let's go on. So that was vertical. What's next? Horizontal. So horizontally, I apparently deleted my graph. That's cool. Don't know where she went. Don't know why she disappeared. Let's put her back. Come back. There she is. You have a graph on yours, right? Okay. I don't know what happened to mine. All right. It's like she never left. Okay. So Let's talk about this. Remember, transformation rules apply to all functions, right? What kind of function do I have now? Absolute value. So our parent function here is an absolute value. Thank you. It's an absolute value. So we're going to start with our absolute value. I intentionally separated your X and your Y. That's because it helps when we change. All right, so we're going to start with the X. Again, we're going to start our smallest X's near 0. Our smallest X is near 0. Okay? Your input can be whatever your heart says I want it to be. Does that make sense? But why would you want big numbers? Don't do that to yourself. All right, what's the absolute value of -3? 3. The absolute value of -2. Absolute value of -1. And if it's already positive, it's going to stay positive. So these are the points that I'm plotting for my absolute value function. For its parent function, the original. My untransformed. And I'm going ahead and plotting out more in hopes of me trying to draw a straight line. All right, there's my f of x. Okay, so g of x. Notice that g of x, your change is inside with the x, right? Because my change is inside with the x. This is my h, which means that it's going to change your x. And what do we say x's were, though? Liars. So even though it looks like I'm actually subtracting, I'm actually doing what? Adding. So for g of x, the change is, to all of my x's, I'm adding 3. Am I making any changes to my y's? No. So my y's are going to stay the same. All right. So we have -3 plus 3. 0. -2 plus 3. 1. And what's going to happen? It's going to keep increasing, right? Because math is about patterns. So 0, 1, 2, 3, 4, 5, and 6. It's going up 1 every single time. You can double check yourself by adding 3. But once you see the pattern, there you go. So my new points are going to be my new x's and my old y's. Or I can go to the parent function and realize that I'm doing what to all of these points? Moving 3 units to what direction? To the right. This is going to make us, we're going right 3. So I'm going to choose this point and I'm going to shift it 3 units right. 1, 2, this point. 1. I can't see from there, guys. I got to do it on this side of the computer. Here we go. 1, 2, 3. Boom. You've been moved. 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 Remember, math is all about patterns. The faster you see the pattern, the less work you have to do. And bam, I've done g of x. So at this point, we should just be working together. You shouldn't be relying on me, right? Because you're catching on to what we're doing. All right, so h of x. On h of x, again, our change is with the x, which means that this is an h transformation, and it's going to affect our x. How am I affecting it? What do we say? We're in left because our x's are liars. So it looks like we're actually, but for h of x, to all of our x's, we are subtracting 3. And if I'm subtracting, then I'm shifting it to the left. So you're going back to the original. And I have -3 minus 3, which puts me at -6. I have -2 minus 3, which puts me at -5. I'm like, oh, it's all decreasing by 1. So here we go. -6, -5, -4, -3, -2, -1, and 0. So I either can plot them as a pair. So I either can plot -6, 3, -5, 2, or I realize that what happened to my red function? Everything was moved what? Left 3 units. So I can go to the red function and say, okay, not the red, the blue function, and I'm going to move them all 3 units left. So 1, 2, 3, here's your new home. Go to this point, 1, 2, 3, here's your new home. And because I realize that's what I'm doing, I can now say, oh, bam, I see the pattern, speed up time. It's really hard to plot at an angle. So I'm going to make mine a little prettier. When I say, do you see the pattern? Is there anyone who's like, I have no clue what the pattern is? Can you please point me in the direction? Oh, man, I thought that was going to be a good one. Close enough. All right. So for this function, the domain and range. Did my domain change? Mm-mm. It still goes forever to the left and forever to the right. Did my range change? No. They all start where? 0, and they all continue to infinity.